As promised, I am here with a video on solving two numericals about vector conversion. We'll solve two questions. One will be small and easy, and the other will not be difficult, but it will be a little bit lengthy and it will have 2 or 3 parts. So let us see this first question. This question has a vector A is equals to 3ax plus 2az, and we have to convert it into cylindrical coordinate. This vector, which is given in Cartesian coordinate, we have to convert it into cylindrical coordinate. So let us start. As I have told you, to convert a vector into cylindrical coordinate, let us first write down the result, the form in which we want the result. Let us say that the result is a vector B. The vector B will have 3 directions: B row, A row, B phi, A phi, and BZ, AZ. So, to find out the first coefficient, that is B row, we will have to find the projection or the contribution of A in A row direction. So, what is the vector A? Vector A is 3ax plus 2az, and we are dot multiplying it with A row. Now 3 will not disturb us, 3 will not trouble us, but this ax dot A row, this first ax and then this A row dot multiplication will have to be found from here. So ax dot A row is cos phi. So we will write 3 cos phi, and then the second multiplication is az dot A row. So az is here, A row is here. So our answer will be 0. So you will write it 2az dot A row will be 0. So let us skip it. Then the second coefficient is B phi. Again multiplying this complete vector A with A phi direction. So A is 3ax plus 2az again, and we are dot multiplying it with A phi. So ax dot A phi, let us see it from here. Ax dot A phi is minus sine theta, so it is minus 3 sine phi, sorry. Then az dot A phi, from the table, z is here, phi is here, the answer is 0, so we will keep it 0, won't write it. Then last coefficient is bz. Bz is equals to, again dot multiplying this complete vector A in z direction. So 3ax plus 2az dot multiplied with az again. So we know that x and az and ax, the dot multiplication of them will always be 0 because they are perpendicular to each other. We can verify it from here also. This is ax and this is az. So the first row and the last column is 0. So this will be 0. And az dot az, because az and az both are same vectors, they are in the same direction. So this last row and the last column will be used. So the answer would be 1. So the remaining term will be 2. So let us move forward. How will we write the answer? See, the answer we have already written. Answer was B row A row, B phi A phi, and BZ AZ, and we have found out B row, B phi, and BZ. So we will just substitute them in that place. 3 cos phi, and the coefficient is A row, minus 3 sin phi, and the coefficient is A phi, plus 2az, and this will be our answer. So that is how a simple question, how you are going to solve. The question was simple, that it asked us to convert a vector which was given in rectangular coordinate. It asked us to convert it into cylindrical coordinate, and that's what we have done. Let us look at the next question. This question has two coordinates, one is P and another is Q. We have to first find out the vector which is made by these two coordinates. So this question is big. Before reading the complete question, let us solve it part by part. So the first part says that at a point P, -3, -4, 4, express that the vector that extends from P to Q. So the vector is extending from P to Q, and we have to first find that vector out in rectangular coordinates. So the points are given in rectangular coordinate. It is very simple to find the vector in the same coordinate, because we have P, we have Q, and the question says that the vector starts from P and goes till Q, and we have that the coordinate of Q are 2, 0, 1, and the P is -3, -4 and 5. So let us write down part A. Part A is finding in rectangular coordinates. So let us name the vector as PQ and an arrow overhead. Arrow tail is always subtracted from arrow head. So we'll do 2 minus -3, that means 2 plus 3, and the coefficient will be AX. Then 0 minus -4 will be +4 AY, and then 1 minus 5 will be -4 AZ. So in rectangular coordinate, our final vector will be 5AX plus 4AY minus 4AZ. So we can say that this is the part A's answer. This is the answer that we were looking for in the A part. Let us now solve the B part. B part says that we have to find the same vector in cylindrical coordinate system. So that is where the first time in this question vector conversion comes into picture. So we have a vector, let's name this vector as PQ, or for our convenience let us name it as A only. So let us say that the final vector that we are going to find out in the part B is B. And as done in the previous question, let us name it in cylindrical coordinate system convention, and it will be B rho A rho plus B phi A phi plus BZ AZ. So again, as previously we have done, let us find out B rho. B rho can be found by multiplying the vector which is given in part A with the direction which is desired, and the first direction that we desire is rho direction. So let us multiply it with A rho. So the answer will be 5 cos phi plus 4 sin phi. So let us leave it like this only. I have used the table. I am not now pointing it out, but I am using the table here as well. To find out B phi, what we will do, we will dot multiply the same vector with A phi. So the answer will be 5, actually minus 5 sin phi plus 4 cos phi. You can verify it. I am looking at the table, I am consulting the table, and then coming up with the answer. And finally, to find out BZ, we will again multiply this complete vector with the AZ direction. This is also dot multiplication. So here also, even without looking at the table also, we can see that AX dot multiplied with AZ will be 0. Y dot multiplied with AZ will also be 0, because these two X and Y's are perpendicular with Z. And only Z multiplied with Z that this dot multiplication will result in 1. So our answer here will be minus 4. So coming up with the complete answer, the way to write it would be 5 cos phi plus 4 sin phi. In bracket we'll write down this direction arrow, then plus minus sin phi plus 4 cos phi in bracket a phi, and then minus 4 az. So this is our second answer. Second part was asking us to convert everything into cylindrical coordinate system. Now let us start the C part. And let us look at the C part again. So the C part says that we have to convert the vector which is 5ax plus 4ay minus 4az into spherical coordinate. So let me put the formula for spherical coordinate, and then we'll start solving the question. The table that we need here, let me put it. So I've now pasted the table that we need for part C. In part C, we have to convert again this vector which was A. A was 5ax plus 4ay minus 4az. We have to convert this vector into spherical coordinate system, and let us imagine that the answer that we are going to come up with will be named as capital C. So it will be CRAR, because we have to find the result in spherical coordinate system. So it will be CRAR, C theta, A theta, and C phi, A phi. So these are the coefficients that we have to find out the answers to. So let us first start with CR. CR, again the way will be similar, that because we have to find out the A, its indulgence in R direction, so we will dot multiply A with R direction, unit vector AR. So it will be 5ax plus 4ay minus 4az dot multiplied with AR. Now this is where we have to look at the table, and we have to be very sure that we are writing things correctly, because this table is a little bigger and it's difficult to remember it by heart, but again with practice you will remember, I hope. So ax dot AR will be sin theta cos phi. So our answer will be 5 sin theta cos phi, then plus y cross AR will be sin theta sin phi. So our answer will be 4 sin theta sin phi, and 4 AZAR is cos theta, so we'll write 4 cos theta. So now let us find the next part, which is C theta. So C theta will be A dot multiplied with A theta. Let us go back a little bit again, and so let me write down the vector again. Dot multiplying this vector A with A theta, and let us see the second column, because we are multiplying things with theta. So A theta is in the second column. Ax dot A theta is cos theta sin cos phi. So 5 cos theta cos phi. Then second row, the center term will be 4 cos theta sin phi, and the last term is minus sin theta. So z dot a phi will be minus sin theta, so it will make this minus plus, so it will be 4 sin theta. This is the coefficient in theta direction, and the last coefficient is c phi. So 5ax plus 4ay minus 4az dot multiplied with a phi. So the answer will be the last column. You can see the last column, this one. So minus 5 sin phi plus 4 cos phi, and that's it. Why? Because see, you can see the last value, the last cell is 0, and it is the answer of the multiplication of az and a phi. So we are doing this az and a phi dot multiplication here, so the last term will be 0. So we are here present with CR, C theta and C phi. Let us do one thing in the last portion which we have not done in the previous ones, that let us find out the value of theta and phi, because the question tells us that we have a point P minus 3, minus 4 and 5, and they are saying to find all the things in this point. Whatever vector conversion is going to take place, we are taking this point as the reference. So this minus 3 is x, minus 4 is y, and minus 5 is z. So let me tell you one thing, that while doing vector multiplication, you will face some problems where we have to do the coordinate conversion also. So this is the place where we are doing coordinate conversion, because we know that in CR, C theta, C phi, all the terms are either in the form of sin theta, sin phi, or cos theta, cos phi. So to find out the value in numerical terms, we will have to find out the value of theta and phi. And we know that theta is equals to tan inverse of under root of x square plus y square and divide by z. So tan inverse of x square is 3 square, that is 9, and 4 4 is 16. So it will be actually under root 25 divided by z is 5. So the answer that we need to find out is tan inverse 1, which will be 45 degree, and phi is equals to tan inverse y by x, which is tan inverse 4 by 3. Minus sign is in both of them, 4 and 3, so we'll ignore it. So tan inverse 4 by 3, you might calculate it to verify my answer. It will be 53.13 degree. So we have theta is equals to 45 degree and phi is equals to 53.13 degree. So let me write down this value of CR. The CR that you see here, we have to substitute the value of theta and phi everywhere in this value of CR, here in this C theta, and here in this C phi. And to save some time, I am writing down the answer directly. The CR will be 1.553. C theta will be 7.209, and C phi is minus 1.6. So this is the last part where we have done some exception, that we have found out the answer in the form of numerical coefficients. I will tell you the reason. See, the last part of the question, which is I think the D part, let me move above. See, this D part says that show that each of these vectors has the same magnitude. So our final task is to find out the magnitude of all these three answers. So I have copied the results of part A, part B and part C, and as we have seen that part A is the vector in rectangular coordinate system, the same vector is converted into cylindrical coordinate system in part B, and the vector A is converted into spherical coordinate system in part C. So we have the same vector in three coordinate systems, and the D part asks us to prove that all these vectors have the same magnitude, and obviously because it is the same vector, just the difference is that it is represented in different coordinate system. It doesn't mean that it is a different vector. So its magnitude should obviously be same. So let us prove it. Find out the magnitude of A. Under root of 5 square, 4 square and then 4 square. So it will be 25 plus 16 plus 16, which will be under root of 57, and the answer will be approximately 7.55. The magnitude of B, you will see that the magnitude of B is, it looks tough but it is very easy. So let us do it quickly, and I hope that you will do it yourself and understand also. So it will be 25 cos square phi plus 16 sin square phi plus 5 4 the 20, and then this 20 is multiplied by 2, so it will be 40 cos phi sin theta. Similarly, the second term, which is minus 5 sin phi plus 4 cos phi whole square, the answer will be 25 sin square phi plus 16 cos square phi minus 40 cos phi sin phi, and the last one is minus 4, so minus 4 will be plus 16. So because the space was not there, okay, let me try to write this plus 16 here itself. So it will be plus 16. So it's very easy to find out the answer, and many of the things will cancel out, like this 40 and this minus 40 cos theta cos phi sin phi will be cancelled, and this 25 cos square phi and this sin square phi can be grouped together. 25 cos square phi plus sin square phi in one bracket, then 16 sin square phi plus cos square phi in another bracket, and 16, the last one, will remain intact. And as you can see that cos square phi plus sin square phi will result in 1, and our answer will be similar to what we found in part A. So our answer will be under root 57 again is equals to, the answer will be 7.55. So the last part is the magnitude of C. See, the first two answers are very satisfying, that both are exactly similar, 7.55. So we hope that the last one also is similar, because we have to prove it that the magnitude of all the three vectors will be same. So we have to find out the square of 1.553, then the square of 7.209 and the square of 1.6 or minus 1.6 is one and the same thing. So I have already found out the answer for you, and it is fortunately 7.55. Happy news. So to conclude, we can say that this numerical helps us understand that a simple vector which is in any one of the coordinate system, if you copy the same vector with the same dimension and the direction, if you copy it in some other coordinate system, its magnitude will not change. Its direction will change, but actually the direction itself is not changing, because we are changing the reference by which we are seeing the direction. This vector A, its direction, we were actually looking with the references of AX, AY and AZ. This B was defined with the directions A rho, A phi and AZ, and this C in spherical coordinate system, it was defined with the help of directions AR, A theta and A phi. So if you want to explain somebody, you can confidently say that a vector, if it is in the same direction, you can copy it anywhere, you can change its coordinate system as many times you want, but because its direction and its magnitude is integral, it's not changing anywhere, so you can definitely say that its magnitude will always be same. So I hope that you understood the first question, which was very simple and small, and this last one was a little bit long, that is why maybe the video is also has become lengthy, but it was necessary that you understand how to convert a vector which is given in one of the coordinate system into other two coordinate system. And numerical might look difficult, but if you solve it with the methods which are traditional methods of the books and the one I explained you will never fail, or you will never be stuck in any of the problems. So thank you, see you in the next video.